Hello everyone, I am Mohit Kartwi, IEEE CS Senior Core Member, and today I am going to explain and will discuss about the basic fundamentals of cloud computing and its application. So we'll look into that. Let's start with the index. Index includes following with the introduction, the basic concepts, what is actually the deployment model, service model, then we have advantages and disadvantages, right? And the fourth is last one is application and deployment. Uh, Basically, in application and deployment, we'll see the real world, the actual implementation of how the cloud is deployed with a small video. So let's see. Now what is cloud? So basically the cloud term that it refers to the servers that are accessed over the internet, and the software which we use runs with the databases on these servers. Now, to provide this internet or the access, cloud servers are located in the data centers all over the world, which are owned by the private companies so far. And this term cloud, actually we can say in a way that cloud is something that presents a remote location, and it can provide the services on the network or for the network, right? And this is how the email or the web conferencing and CRM, all these services run on the cloud. Next is what is cloud computing. Now, so far we discussed that what is cloud. Now, cloud computing. Cloud computing is simply, if I put in simple words, it is actually a delivery of computing services that includes servers, storage, databases, networking, software, analytics, and intelligence. Everything on the cloud, that is over the internet. So, to offer faster, flexible, reliable, innovation, and economies of the scale. So that is why it was much needed for a domain which can overcome the hurdles and the challenges of the traditional data centers, and that's where this cloud computing came into the demand. And so far many of the scientists and top renowned chief executives say and believe that cloud computing is the next real world emerging technology. Also, some people relate it to cut edge technology, state of the art, right? And that's how cloud computing is, as mentioned, it refers to the manipulating and configuring and accessing the applications online. Also, it offers data storage, infrastructure, and application. Right. And just to make it into a terminology, it is actually the combination of the software and the hardware-based computing resources delivered as a network service. So that's what we earlier discussed. We'll move to the models of the cloud computing. Now, see, models of the cloud computing is actually it's divided into three main categories. But before that, I would like to add that it's a domain. So it is actually a domain that is service oriented over the internet, and it is classified into three main categories. That's what I was trying to convey. Mainly the three categories are IaaS, that is infrastructure as a service, platform as a service, that is PaaS, and software as a service, that is SaaS. We'll one by one go into all the basic fundamentals of these terminologies, and also learn what are the merits and the demerits of these service oriented models. We'll move to the next is the first one is the infrastructure as a service. Now what actually is that it has this service was first introduced, and it was too much attractive because acquiring the computing resources to run the applications, and also in comparison to the traditional data centers, it was much more reliable for the companies to scale up their growth. Also, this model provides an on-demand access to the computing resources, maintaining storage for your organization, then taking care of the network, right? That is LAN, local area network, or is it WAN, WAN, that is wide area network. And now new terminology has came is MAN, MAN, that is metropolitan area network. So it provides, or through this services provides into the various types of network areas, and organizations are frequently using this because it is much more reliable. However, all this is challenging to scale when the demand spikes, or our business grows. You run the risk of running out of the capacity, or overbuilding and paying for the infrastructure that you never use. So this is one of the challenging hurdles for the IaaS. The next is platform as a service. It is similar to IaaS model, but here what actually happens is the service providers manages your backend infrastructure. So you may maybe scalability, maybe feasibility. You can also get a dependency for the way, we can say, right, scalability, then reliability, right? And similarly, it provides all the software features and the tools needed for handling the backend infrastructure. It also helps for the deployment, and gives much more tools to use, the which can be useful for the developers. And you still have the right to code and manage your apps and data, that do not worry about maintaining the software development. However, it also has many challenges, that includes the first is vendor dependency. Now, this is one of the most critical factor, which gives a dependency on the vendor, that is your service provider. Second is risk of lock-in. Now, here there is a high chance that the customer may get logged into a particular language or an interface, and the program is they which they no longer need it. Third issue is the compatibility. Now, difficulties may rise in platform as a service, and it can, in terms when there is a conjunction with the existing development platforms. However, to overcome these somehow issues, new service was introduced, that was SaaS, which is quite reliable and used through the industry currently. And it actually is a distribution model, and we'll go into the content first, which actually delivers the software applications this over the internet. And these applications are often called web services. Like we have Amazon Web Services, we can have Google GCP, we have Azure. So these are the services. Now users can, so we were talking, that is the SaaS model. It's a user gain access to application, and the most useful factor for this service is that the infrastructure or the tools required to develop are given more access and more control to the developers or the developer team in this type of cloud deployment model. And we have one of the most common example is the Microsoft 365, which is used worldwide, popularly known for its productivity and the email services, right? And with this SaaS model, the service provider is actually delivering the entire application stack. That is, the you have the complete application and all the infrastructure needed to deliver it. And as a customer, all you have to do is to connect to the app through the internet, and the service provider is responsible for everything else. That's the main motive of this software as a service cloud platform. We'll move into the pictured schematic diagram of the difference between the SaaS, the PaaS, and the IaaS. Here you can see the less control is given to the SES, and the software developers are in the middle step, which provides platform as a service, right? And the more control is given to the IaaS, where you have the IT administration services using this model. So for end users, the SES is the best model, and that's why it is more common, popularly known in the market industry today, and it gives the end user a quite good exposure for various applications of the cloud deployment. Next, we have what is cloud deployment model. The cloud deployment model is actually functioning as a virtual computing environment with a deployment architecture that varies depending on the amount of data you want to store and who has the access to the infrastructure. There are various deployment models. We'll one by one go through it. They are classified into various types. Now this cloud deployment model varies from person to person or organization to organization. Few organizations require have some other requirements, where few of the other companies have their own other requirements. So that's why the scientist community or the cloud domain community came up with few various types of cloud deployment models which are feasible and possible for their own personal uses. And the deployment model actually helps based on the ownership or the scale and access, as well as the cloud's nature and the purpose. They are identified in such a way. The location of the servers you are utilizing and the who controls them are defined by a cloud deployment model. So we'll move into one by one model, and here are the list of few deployment models. I must say, actually, it covers all the deployment models. There are basically four deployment models that are main. First one is the public, second one is the private, third one is the hybrid, and fourth one is the multi cloud deployment model. We'll come one across one by one. The first one is the public deployment model. Now what actually happens in this is, it is mostly scalable or it is cost effective. So, and it gives the access to the global computing resources, such as hosting a website or large scale applications where the end users are more in terms of busy, a busy app that we call it, which does gives a full flexible and soft service. So that's where the public deployment model is used. Main its advantage is it has a minimal investment, it has no setup cost, and infrastructure management is not required. Third one is there is no maintenance. And the disadvantage that public deployment model has is it is less secure and it has low customization for an end user, right? Or it can be even the organizations. The second model is the private model. Cloud private deployment model is much used, right? It was used. However, we'll go into that. It is actually a design for the enhanced security and the control, which is suitable for the industries with the strict data compliance requirements like healthcare and finance. These are the two important infrastructural departments which requires enhanced security with the control over your data access, right? Which follows the strict data compliance requirements. That's why it has few advantages that are, it has a better control, it has a data security, it has privacy, it supports legacy systems, it is customizable. So for organization to organization, you can customize your requirements and serve your service for the end users through the private cloud model. So it is much more flexible, and it has as well a demerit, that is it is less scalable and it is costly. Since because it is customizable, so it is costly and it is not cheaper option, right? The third model that is quite used, and it is a dynamic model, that is hybrid cloud deployment model. Now what happens is it is a combination of the public and the private clouds for servicing, for flexibility, and it is suitable for the businesses with the dynamic workloads and a data sensitive task. However, it has a few demerits. For suppose it is difficult to manage, it is slow in terms of data transmission. However, as well, it has few of the most common advantages. That is, it is flexible and it is controllable. So you have the control over what to deploy and what not to deploy, what to in which terms of you to give the service and in which terms it not. And the second factor is the cost factor, and it has also a security. So these are the advantages of the hybrid deployment model. Now we'll come across the last model, that is multi-deployment model. Now multi-deployment model is it is a utilization of the multiple cloud providers to a vendor lock in and optimize performance, making it suitable to diversify the workload into the management and the disaster recovery. What it actually tries to convey is that it is first of all a collection of the multiple cloud providers, and it gives a optimizable performance which is used for the business organizations to diversify the workload management, and also it is helpful for the disaster recovery management. Now suppose if a company loses its data, so in terms of to get back the backup or the data, there is a terminology, that is disaster risk recovery management, DRM. This cloud deployment model helps the organization or the business to get back that data and secure them and store them with the high availability of services, right? So that's why few of the advantages such as reduced latency, it has high availability of service, and in terms it is cheaper. Third, it has few disadvantages, is it is complex, it is not less complex, it is highly complexable, and it has security issues because it is handled by the cloud providers, it is less secure and there are security or the privacy issues. Now next, we'll move to the advantages of the cloud computing. So far we discussed what are the services that cloud computing provides, what are the different types of models that cloud computing has for the public, and now we'll come across the advantages. The main advantage is it is lower computer cost. So you have the terminologies like distributed computing system and standard computing system, or you can say parallel computing system. Now, what happens is you give the task simultaneously to both the computing models, but the faster one will be the parallel computing process. Why? Because in distributed systems, when 4 plus 5 plus 6 plus 7 is given, it will first try to add 4 plus 5, then the result will be added to 6, then that result will be added to 7, and then the calculation will be given. Whereas in parallel computing, the tasks are simultaneously divided. It actually works as a distribution of the task, which gives the faster and flexibility in terms of computation. That's why it has lower computer cost when it comes to cloud computing. Improved performances, reduced software cost, instant software updates without knowing the end users whether the software is updated, in terms of the changing of few of the packages installed and libraries to be set. It actually works as a boon for the developer team to, without harass the end users, it can change the updates and give the required updates or change the various updates. It has the improved document format compatibility. So you have a Git example, or Git, right? Git is actually a clone repository where you can document the changes that you have made. You have the unlimited storage capacity, you have gigabyte, you have terabyte, you have petabyte, you can extend up to zettabytes, right? And it has increased the data reliability. Reliability in terms of what you are giving as a sender is the same amount that is received by the receiver without any interruption in between. That is called the reliability. Universal document access, latest version availability, you have easier group collaboration. That's what I gave the example for Git. And there is a device independence. So no matter in whichever device you are working, cloud computing can serve in all the uh, computing models or the devices which are equipped for cloud computing. The next is disadvantages. Every coin has two sides, so disadvantages comes along with the advantages. That's why we should discuss this. That includes that requires a constant internet connection. Now, if you have a low unstabilized internet connection, you may see a working problem or the hurdle for smoothing, or the smooth functioning of your service. So constant internet connection is required. It does not work with the low speed connection. It features might be limited. It can be slow. It can be stored data can be lost. So that's why disastrous recovery management, that's what we discussed earlier. Stored data might not be secure. As we also discussed, there are privacy reasons, there are concerns regarding high security is not provided. So these are the some of the disadvantages of the cloud computing. Next, we will move across its application. The last part of our cloud computing today's session is application. So one by one, we'll discuss what are the various applications of the cloud computing, right? The next one is the cloud native. Now, what actually cloud native is? So, cloud native is a term which was recently discovered, and it is new for the community, cloud domain community. So, what actually is it is the cloud native is actually a services which empower the modern application deploy development using the technologies such as Kubernetes, Docker, serverless functions, APIs, and Kafka. Now, these names, what I just mentioned before 1 second, we'll come across one by one, and we'll explain it in detail. So, industry leading cloud providers, this enable their cloud tooling and services so that the developers can reduce the operational tasks and build the applications faster. That's where the role of a cloud native comes. Now, cloud native is more than simply taking the existing apps and running them in the cloud. That's what is the main job of a cloud native. It is a software that approaches the building, developing, and managing the modern applications in the cloud computing environments. To do so, we have the modern tools and techniques that are inherently supporting the application development on the cloud infrastructure. So you need to code somewhere, you need to choose somewhere, and based on your decisions or choosing factor, it can vary from organization to organization or business to business. It can vary. However, on the cloud infrastructure, it will serve as your main purpose or a motive. These cloud native technologies support fast and frequent changes to the applications without impacting the service delivery or providing adopters with an innovative competitive advantage. Next is, but before that, uh, if I can put the cloud native into simple terms, it is a software that is built to run in a cloud computing environment. That's the simple one line word I can refer to cloud native. We'll move across the next slide. that is cloud native applications. Now, cloud native applications are much into a real world or real time use. It has a real time usage, I can say. So what actually it is, we'll go through the content, that it is actually a software program that consists of the multiple small and interdependent services called microservices. I'll come across this terminology in the next slide. However, traditionally, developers used to build the monolithic applications with a single block structure containing all the required functionalities. So you had a monolithic OS operating system which used to serve these applications in a single layer, where you have as a demerit, you had a security issues, you had reliability issues. So to overcome this type of cloud native applications were discovered in terms of microservices. Now, it actually software developers, they believe that they can break the functionalities into a smaller microservices, which is helpful for them to deploy easily. This makes the cloud native application more agile, as these microservices work independently and take the minimal computing resources to run. As a matter of fact, it is to be noticed that the cloud native architecture combines the software components. The development teams use them to build and run the scalable cloud native applications. So in 2015, CNCF, Cloud Native Community Foundation, uh, lists some immutable infrastructures and the microservices, as well as APIs, containers, and services as the technological block of cloud native architecture. So we all these terminologies, we should explain them in the next to next slide. However, this is basic architecture, how it looks like for cloud native architecture. You have microservices, you have DevOps, you have CI/CD, that is uh, designing of compiler, containers, modern designs, and then mixing up of this is the architecture that is called cloud native architecture. Now, there are benefits of cloud native architecture. We should discuss one by one. So you have container orchestration tools like Kubernetes, which is quite familiar in today real-time industry, which allows the developers to coordinate the way in which an application's containers will function. So you have Swiggy, for example, Zomato, all these apps run on cloud models. Now, for deploying these cloud models on maybe a platform that is Play Store, you need cloud. And for that, developer teams group or build a cloud native uh, application which is friendly to the end users, and it is scalable in the other hand, and it is easy to deploy for them. Otherwise, it is really a tedious task when it was earlier. If you anyone wants to deploy a application on previous before 5 or 10 years, it was much a tedious task. So now it has become easy for to deploy through cloud native applications. Now, using this cloud native approach, it actually saves your money. It reduces the time spent on the maintenance. It is easy to scale through the cloud orchestration. So you have the container schedulers, and meaning of more time can be spent focusing on the business goals. So businesses like JP Morgan or Flipkart or Amazon use cloud services for the cloud native applications. They build in such a way that they can focus more on their business and taking less about the updation or the critical actions to be taken in disaster. So that's where the cloud native applications serve as a benefit or the boon. Next are the examples. Let's come across a few terminologies which are very interesting in cloud native applications. So we have software defined infrastructure, that is SDI, containers, microservices, and APIs, which are the common various familiar examples of cloud native applications. So CDI is actually, it abstracts and virtualizes the hardware resources for the flexible management in the cloud. So it provides as a platform, as an infrastructure which takes care about virtualization. Now, virtualization in terms of combination of a hardware resource and a software resource, which can be easily manageable, and it can be easily deployed. That's where the role of SDI comes. So we have SDI engineers in few of the cloud companies. The next one is the containers. Now containers are containing or offering efficient or the portable application that deploys and scales in the cloud. Containers, that's earlier what we discussed, provides a tool or a software tool particularly to scale your application. When a Swiggy or a Zomato or a Flipkart or an Amazon cloud engineer wants to deploy this app or the new update in the Play Store, these containers or the service tools help them to easily deploy on the Play Store. Without this, it is much a tedious task to deploy them. So containers are a set of predefined services or tools which help in various factors or various departments to launch or to update or to get uploaded, or you can say deploy application, right, on any of the platform. Third is microservices. Now, microservice is very new terminology. We'll break it. So, microservices breaks the application into the modular, cloud-ready services for the flexibility and the scalability. It actually helps works along simultaneously with the containers. However, many of the students or people mixes the containers and the microservices with one another, but actually they are not. Microservices are used by the developers or the DevOps engineers to break down the into the molecular parts. So if an application is there, so you have the UI UX designs, or you have the front end, or you have the back end, where you need developers to handle the back end of the application for friendly with the operating system. So these are the microservices which cut down or break down into various factors to provide easy or reliable services to deploy the application into the Play Store uh, or App Store, right? And APIs. Now, APIs are application programming interface. They are useful in much today real world industry. APIs enable the communication and the integration between the cloud services, applications, and components. So I can give the most common example of API is Google Maps. So if I have ordered online delivery food on a any of the Swiggy or the Zomato app, we can track the location of the delivery agent uh, through from the restaurant to our home, and this is only possible with the Google Maps API. So we can actually track and see where the delivery agent has reached, that is the food partner, right? So Swiggy or Zomato or Uber or Ola, all these apps uses the Google Maps API for building or for the interface of their own deployment or the cloud applications. So all mostly applications today existing in the Play Store or App Store are using cloud models or cloud developments, and including microservices, containers, APIs, and STIs. So you have a completely much deep domain known as DevOps, which handles all this virtualization and cloud computing workloads, right? We'll move to the next slide, and we have one uh, demo video for how a project is deployed on the cloud. Let's see this.
Everyone, I'm back with hit on another video. This video is about deploying a sample application on GCP App Engine. Google Cloud Platform offered by Google is a suite of cloud computing services that runs on same infrastructure that Google uses internally for its end user products like Google Search, Gmail, Google Drive, and YouTube. Everyone, I'm back with hit on another video. This video is about deploying a sample application on GCP App Engine. Google Cloud Platform offered by Google is a suite of cloud computing services that runs on same infrastructure that Google uses internally for its end user products like Google Search, Gmail, Google Drive, and YouTube. Apart from management tools, it provides series of modular cloud services like computing, data storage, data analytics, and machine learning. GCP provides infrastructure as a service, platform as a service, and serverless computing environments. In 2008, Google announced App Engine, a platform for developing and hosting web applications in Google managed data centers, which was the first cloud computing service from the company. Google App Engine is Google's platform as a service offering that allows developers and businesses to build and run applications using Google's advanced infrastructure. And these applications are required to be written in one of the few supported languages like Java, Python, PHP, and Go. Click Select a project. In that, click New Project and name the project. And click on Create. And now the job is submitted for the project to be created. And the project has been created now. Now activate Cloud Shell. Now execute the command gcloud projects list. It shows me that this project has been created and it has the project ID, project name, and number associated with it. Now we have to work in this project. This project need to enable App Engine API to use App Engine. For that, navigate to API services in the menu. And in the top, we have a button called Enable API and Services. Click on the plus icon and search for the API which we need to enable. And select App Engine Admin API. This is the API we need to enable so that we can build application on App Engine. App Engine take care of all the backend compute and it is a serverless platform for developing and hosting web applications. And now we can see the activation status that is enabled. Now come back to the console. To navigate to our project, there's a simple command that is gcloud config set project and pass the ID of newly created project so that I will be navigated to the newly created project. App Engine in menu. It will show me that I can create my application. To create an application or activate an App Engine, you can do this by clicking create application, or you can execute the command gcloud app create. To create an application engine, go back to console and see it says that the App Engine application has been successfully created. Now to deploy the application, I have taken an official repository and cloned it. I have posted the link of this repository in the description menu for you to use. Click the code button. In that, copy the link. Run the command and paste the link followed by git clone. Again, change to the directory that contains the sample code, that is hello world. And here you can see the files like main.py and app.yaml. Each service in your app has its own app.yaml file, which act as a descriptor for its deployment. And this file contains the information about your app's code such as runtime and latest version identifier. Main.py is a file which contains our hello world program. Now give cat command followed by main.py to view the contents of the file. And this is a simple Python Flask application. Now run the file as python3 space main.py. Go to the URL and you can see your application is running now. Or you can use the web preview toolbar in the Cloud Shell and select preview on port 8080. The hello world message from the sample app is displayed on the page.
So this is where how a small project was deployed using a GCP app engine to deploy uh, through cloud. And we'll move fast into the next statistics, just more emphasizing that it is believed that in 2025, 175 zettabytes of global data sphere will grow, and from 33 zettabytes, which was in 2018 earlier, it increased to 175 zettabyte to in 2025, and IoT devices are much more expected to create over 90 zettabytes of data in the next upcoming years. And in the next photo or diagram graph, you can see through the various hostings cloud services, few of the service providers are scaling up year on year. And the next is one of the most eye-catching statistic is it is believed in 2030 that more than $1 trillion run rate EBITDA across the Fortune 500 companies will grab up. So the cloud cost optimization is leveling, and it is value-oriented business. That's why the most of the top company chief executives believe that cloud computing is a real world cut edge technology. And here comes our end. So we are thanking you for taking up this session. If you have any doubts, please ask in our below website, and you can follow us on Instagram, Indeed, and YouTube. Thank you very much.